If life is common in the universe, why does the universe feel so quiet? We look out into the night sky and see a universe that is vast beyond comprehension. Hundreds of billions of galaxies, each galaxy holding hundreds of billions of stars. And around many of those stars, planets. Statistically, this should be a crowded place. And yet, no voices, no signals, no visitors, no unmistakable sign that anyone else is out there. If the universe is full of life, why does it behave as if we are alone? This question refuses to fade. It returns with every new telescope, with every new exoplanet, with every advance in our understanding of biology and chemistry, not because we lack imagination, but because the silence keeps surviving our best explanations. We know this much, and it matters more than it first appears. Life on Earth did not wait patiently for billions of years to begin. Once the planet cooled, once water settled on its surface, once chemistry had room to operate, life emerged with surprising speed. In cosmic terms, it arrived almost immediately. That alone tells us something important. Life does not necessarily require perfect conditions, only possible ones sustained for long enough. The raw materials of biology are not exotic. Water is abundant. Carbon-based molecules form naturally in interstellar clouds, on comets, and within protoplanetary disks. Energy, whether from starlight, chemical gradients, or geothermal heat, is readily available across the galaxy. These are not rare coincidences. They are common features of planetary systems. We also know now that planets themselves are everywhere. Most stars host them. Rocky worlds, similar in mass and structure to Earth, are not exceptions. They circle ordinary stars in stable orbits, some at distances where temperatures could allow liquid water to persist on their surfaces for billions of years, long enough for complex chemistry to unfold. From a purely scientific perspective, the universe does not seem hostile to life. It seems prepared for it. The stage is vast, the ingredients are scattered generously, and the time available is immense. And yet, there is a crucial distinction we cannot ignore. A universe that can produce life is not the same as a universe that does. Possibility is not evidence. Capability is not confirmation. And so, even with all that we know, the most profound question remains unanswered, quietly waiting in the space between expectation and proof. Here is where the problem sharpens, and where curiosity begins to turn into unease. If life emerges readily under the right conditions, and if intelligence is not an anomaly but a natural extension of evolution, then the galaxy should not be silent. It should carry traces of activity, faint, scattered, imperfect, but detectable. Not everywhere, not in every system, but somewhere, in a universe this old and this large, signs should remain. Technological civilizations do not need to announce themselves to be noticed. Radio signals leak unintentionally into space. Energy use, leaves, fingerprints. Large-scale engineering altered stars, modified orbits, artificial illumination would disturb the natural order in subtle but measurable ways. Even a planet's atmosphere can betray intelligence, showing chemical imbalances that biology alone struggles to explain. And yet, when we look with our most sensitive instruments, the result is the same. The sky remains quiet. Searches return noise, not messages. Patterns dissolve under scrutiny. No signal repeats with intent. No structure survives explanation. No artifact refuses to be dismissed as natural. We know A with confidence. The universe is ancient, vast beyond intuition, and rich in the chemistry required for life. But B refuses to cooperate. The evidence we expect does not appear. Instead, we encounter an overwhelming, persistent silence. This gap between what theory suggests and what observation delivers is not a minor inconvenience. It is the central tension of the question itself. A universe that should be speaking, but isn't. And in that silence, the mystery takes hold. The first possibility is unsettling in its simplicity, precisely because it asks us to lower our expectations rather than expand them. Perhaps life is not common at all. Perhaps the moment when chemistry crosses into biology is not a natural consequence of the universe's design, but an extraordinary statistical fluke. Molecules may assemble, oceans may form, and energy may flow, yet life may still fail to ignite. The spark we call biology could require a sequence of conditions so precise that it occurs only rarely, even across billions of worlds. In this view, Earth is not representative. It is an outlier, a planet where countless unlikely events aligned in just the right order, at just the right time, and never repeated elsewhere. The universe may be filled with planets that appear promising from a distance, blue, temperate, and rich in chemistry, yet remain forever silent. Oceans without metabolism, atmospheres shaped only by geology, worlds that never cross the invisible threshold separating matter from life. If life itself is rare, then intelligence would be rarer still. Not the inevitable outcome of evolution, but a fragile anomaly balanced on improbable foundations. In that context, the cosmic silence stops being mysterious. It becomes expected. But this explanation carries a heavy implication. It suggests that Earth is not merely one inhabited world among many, but something profoundly uncommon. Not just special in location or history, but precious beyond measure, because it may represent one of the very few places where the universe learned how to live. The second possibility is darker, not because it denies life, but because it questions endurance. Life itself may arise often. Simple organisms may thrive across countless worlds, adapting, multiplying, and evolving wherever conditions allow. But the leap from biology to lasting intelligence may be far more precarious. The journey from a single-celled organism to a thinking species takes immense time, stability, and chance. The journey from intelligence to extinction, by contrast, may be alarmingly short. Technology changes the balance. It multiplies power faster than wisdom can mature. Energy sources become weapons long before they become safeguards. Communication expands, but so does surveillance. Progress accelerates faster than social, ethical, or biological limits can adapt. Each advance increases capability, and with it, the risk of collapse. In this view, civilizations do not fail because the universe is hostile. They fail because they are unstable. They erase themselves through conflict, environmental exhaustion, or runaway technology before they can spread meaningfully into the cosmos or leave a lasting signature behind. If this pattern is common, then the universe could be rich with biological life and still nearly empty of enduring intelligence. Worlds may teem with ecosystems, while technological civilizations flicker briefly and vanish without a trace. In that case, we may be early. Or we may be typical, standing for a moment at the edge of a long, repeating story that ends quietly. From this perspective, the cosmic silence is not emptiness at all. It is a graveyard of unrealized futures, each one ending before it could be heard. The third possibility does not diminish the universe. It challenges our assumptions about it. Perhaps advanced civilizations do exist, but not in the forms we expect, and not in ways that align with our methods of searching. Our ideas of technological progress are shaped by human history, by expansion, visibility, and constant signaling. But there is no guarantee that intelligence elsewhere follows the same trajectory. An advanced civilization may not rely on radio at all. It may have moved beyond noisy, inefficient forms of communication. It may not expand outward across stars, driven by conquest or curiosity, but inward toward efficiency, sustainability, and stability. Growth, in this context, would not mean colonization. It would mean refinement. Such intelligence could leave behind signatures too subtle for our instruments to recognize as artificial. Its technologies might blend seamlessly into natural processes, or operate on scales of time that escape our brief observational windows, too fast to detect, or too slow to notice. What appears to us as absence may simply be unfamiliarity. There is also the possibility that contact is avoided deliberately, not out of hostility, but out of restraint. A civilization that has endured long enough to become truly advanced may have learned that broadcasting one's presence carries risk. Silence, in that case, is not ignorance, it is caution. Seen this way, the universe is not empty at all. It is reserved, quiet by choice, not hiding life, but practicing discretion beyond our expectations. One discovery would be enough to change everything. Not a dramatic arrival, not a spacecraft crossing our skies, not a message etched in numbers and sent across the stars. The universe would not need to shout to be understood. All it would take is one unambiguous sign of life beyond Earth, a confirmed biological signature in the atmosphere of a distant world, a persistent chemical imbalance, oxygen coexisting with methane, or compounds that should quickly destroy one another unless something is actively replenishing them. A pattern that points not to geology or chemistry alone, but to metabolism, growth, and reproduction unfolding over time. Or, alternatively, a signal that carries structure. Not random noise, not statistical coincidence, but intent. A transmission that repeats with purpose, that resists natural explanation, that reveals design rather than chance. Any one of these would collapse decades of speculation into a single moment of clarity. Entire theories would reorganize overnight. Humanity's place in the universe would shift instantly, not through philosophy, but through evidence. Until that moment arrives, we occupy a strange position. We live in a cosmos rich with possibility, filled with worlds that could host life, and yet we remain constrained by what we can prove. Between what might be and what is confirmed, we wait, listening carefully, knowing that one observation could redraw everything we think we know. If life is common, why does the silence persist? We know that the universe builds planets and chemistry with remarkable ease, assembling stars, worlds, and molecules on a scale that defies intuition. Yet when it comes to intelligence, something capable of reflection, intention, and memory, the cosmos leaves no obvious trace, no signatures that endure, no voices that answer back. To explain this, scientists offer possibilities rather than conclusions. Life may be rare, intelligence may be fragile, or perhaps we are misreading the universe entirely, listening for the wrong signals and expecting familiar forms where none are required. Each explanation is plausible, none are complete, and so the question remains unresolved. One observation, a single, undeniable piece of evidence, could transform everything we believe about our place in reality. But until that moment arrives, uncertainty remains our constant companion. Perhaps the deeper truth is not about them at all. Perhaps this question refuses to disappear because it reflects something fundamental about us. Our need to know whether consciousness is a cosmic accident, a brief anomaly in an indifferent universe, or a recurring feature woven into the structure of reality itself. Until we hear another voice, we continue the search quietly. We listen, we observe, we wonder. In this moment, we are the universe asking itself if it is alone. And for now, we are the only answer it has.